All right. So, again, I'm going to take you to that app. We're going to look at sine, cos, and tangent. We'll start with sine. So the black graph is our graph of sine. And right at 0, does it make sense, or does it appear that the slope of that line is going to be 1? Does that seem reasonable for that red line? What do you think the slope's going to be at pi over 2? 0? What do you think the slope's going to be at pi? -1? So if we test that out, if I go up to pi over 2, yes, it looks like it's at 0, and at pi it's at -1. Then it goes back to 0, and we get this graph. And it's just, you imagine, since it's snowing today, that you're on a toboggan. Woo, woo. Oh, fun. Anyways, so there we have our blue graph. That blue graph is the graph of all of those slopes, and we put all of those slopes together. It seems to look like a graph that we know. What is that blue graph? Cos. And so the derivative of sine is cos. What do you think the derivative of cos is going to be? All right, we'll check it out. Here we go. Here's our cos graph. Does it make sense that starting off it's at 0? What's it going to be at pi over 2? -1, and at pi 0 again. There we are, getting ready on our toboggans. Oh, there we go. Whew. So our guess was the derivative of cos was sine. Is this sine? No, this isn't a sine graph. What is this? It's a negative sine graph. Okay, so we were close on our guess. What do you think the derivative of tangent will be? Cotangent? All right. Is that enough tangent graphs for you? Are you ready? No? It looks a little scary because it could fall off, right? So, there we go. Fill them in. What I like about the tangent graph is you can really see that this program is just plotting points as I go. So like if you want to fill in things, you really got to work at it. Oh, there we go. Anyways. All right. Anybody know what the repeating parabola-like graph is called? Where did we have graphs that had parabolas above and below? They're not parabolas, but they look like parabolas. Cotangent looks like the tangent one, but like negative x cubed graphs. What were these ones called? They're a reciprocal of sine or cosine, right? So those graphs would be secant and cosecant. Now, which one had this one right here? Would that be secant or would that be cosecant? It would be secant because it would be the reciprocal of cos, because cos starts here at 1. Now, if I wanted them all positive like that, how could I do that? How could I take a secant graph? You could make it absolute value. That is one way. And there's another way that you can make them all positive. And that is square them. So the derivative of tangent is secant squared. Whew. Oh, and we are just starting to have fun. No. All right, let's. We're going to open up the floodgates to derivatives in the next couple of days. We are just getting started. So, the derivative of 4 sine x would be, yes, 4 cos x. The derivative of negative 1/3 cos x plus tan x plus 3x cubed. Well, that would be positive 1/3 sine x, because the derivative of cos is negative sine, plus secant squared x plus 9x squared. So we, again, can do the derivative of each one separately. And now we have a sine 2 theta. We have not learnt how to do derivatives with a 2 inside of sine. We haven't learned how to do derivatives if we divide. So we got to use our identities to rearrange this. Sine 2 theta is 2 sine theta cos theta. The sine thetas nicely cancel out. That leaves us with just 2 cos theta. And the derivative of cos is negative sine, so we get negative 2 sine theta. Now, the way that I remember that the derivative of cos is negative, which is my cos one here, right here. The way that I remember that my derivative of cos is negative sine is if I think about starting right here at the starting point, and I think about my slopes. As soon as I move a little bit to the right, can you see that my slopes are negative? And that will cause this graph to go down first rather than up. And so the fact that I'm going down at the beginning means my slopes start off negative, and that helps me remember that the derivative of cos is negative sine. I mean, these things are on your formula sheet, but you will memorize them, or you will use them so often that you will memorize them. Like, do you have to look at your formula sheet each time you do x cubed, you bring the 3 out in front and subtract 1 from the exponent, or have you already memorized that? Probably already have memorized that. You could look at your formula sheet every single time, but time-wise, you'll run out of time to do that on exam. So now we could find the equation of the tangent and the normal if we wanted to of sine x at the origin. So how do we find equations of tangent lines? We start with the derivative. Derivative is cos. At x equals 0, which is the origin, what is cos of 0? Cos of 0 is 1. And yes, you need to know your unit circle, your pi plate values. And then once you have your slope, what's your point? You've got your slope is 1, your point is 0, 0. So there's our tangent. With our normal, the slope would be negative 1, the point would be 0, 0. There's our normal. There's a picture of it on a graphing calculator. And that's where we'll stop. We will get to rule number 5 on Wednesday. And that's when things really start to get fun.